Hi there. Once again, I'm Steve Smith, aka Ardalis, and in this module, we're going to take a look at best practices and considerations for designing the models used by your web APIs. The models we're talking about here are the things your API accepts and returns over the wire, typically serialized as JSON or perhaps XML. Let's get started. In this module, we're going to start with some basic best practices for your web API models. Then, we'll introduce and talk a little bit about the robustness principle and how it applies to web APIs and the models you accept and return. Then we'll discuss how to decide what data your APIs should return depending on context. And then we'll look at some of the characteristics of good web API models as well as some anti-patterns that might indicate that your models aren't as good as they could be. Let's get started with the basics of web API models. The most important takeaway is that your web API models should almost always be DTOs. So, what is a DTO? A DTO is a data transfer object. Data transfer objects are objects that have no behavior, only state, just properties, no encapsulation. Many people confuse these with POCOs, which is another acronym. A POCO is a plain old CLR or C# object. DTOs are POCOs since DTOs generally just inherit from system.object. But not all POCOs are DTOs since a POCO could have methods and therefore behavior. Why should your API models not have behavior? Because their only purpose is to be serialized and deserialized into a text format, which is then sent over the wire. At a minimum, your model types should be focused purely on transferring data. That's it. That's their sole responsibility. Make sure they're just DTOs. To define your model DTOs, you can use C# record types or classes. Record types can work for many situations and often require substantially less code. Remember that even though your model objects don't have behavior, they can still include annotations to support model validation. Model validation is built in to ASP.NET Core MVC controllers that use the API controller attribute, so you should certainly take advantage of this feature when you can. If possible, resist the urge to just define a small set of DTOs. Name them each, entity, whatever DTO, customer DTO, order DTO, etc. Instead, wherever possible, provide your model types with intention-revealing names. Naming is hard, but you can make it easier if you use something like create author request instead of just passing around an author DTO for every single one of your methods in your web API. For DTOs that are used to create new resources, I like to name them something like create resource command or create resource request, replacing resource with the name of the resource. In this example, you can see that it's a class and it includes 3 string properties, name, Pluralsight URL, and Twitter alias. Because it's a DTO, there is no encapsulation. That means there are no protected, internal, or private accessors. Everything is public. And because it's used for creation and the server is generating the keys, there is no ID property. Even though it's a DTO, we're able to add annotations from the system.componentModel.dataAnnotations namespace. We are using these to mark the name property as required and to specify maximum lengths for each property. Because we used constants to define the data model lengths, we're able to reuse those constants here, which ensures that they stay consistent. If you prefer, you can use records for your API models, which can result in much less code. In this case, it doesn't look much shorter, but that's only because of the annotations that are being used. When you don't need to use annotations, especially for your response types, records can provide a much more succinct way to define your models. When designing the models to use with your web API, you should keep in mind Postal's law, also known as the robustness principle. It applies to systems that must interoperate with one another. Postal's law states, be conservative in what you send, but be liberal in what you accept. It was coined by John Postel, who used the wording in an early specification of the TCP protocol. In practice, this means that when your programs call out to other programs, they should adhere to the expected interface exactly. But when other programs call your program, you should accept requests that aren't perfect as long as their intent is clear. Applying this to web APIs, what you accept are HTTP requests and what you send are HTTP responses. You should take care to adhere to standards and specifications and your own documentation with anything you send, but you should be more forgiving with what you accept in order to ensure your APIs are easy to use and bend a little before breaking over time. The robustness principle is often credited with much of the success of the protocols that underlie the Internet. Although your services may not have the same reach as TCP or IP protocols, you can still apply the same principle to the benefit of your services and their clients. A related law is Hiram's Law, and the importance of Postel's Law becomes more clear when you couple it with Hiram's Law for APIs, which states that with enough users, regardless of what you might commit to in your contract, all observable behaviors of your system will be depended on by somebody. The more consistent and constrained you can be with your responses, the less likely you are to inadvertently introduce breaking changes to some of your clients. As an example, let's say that I want to change how I accept a Twitter alias into my APIs. Let's assume that the API has been in use for a while, and the data in my system now has aliases in a variety of formats. Some use an @ prefix, some don't. Some include the full URL. So my solution to try and fix this problem with data coming in different formats might be to apply stronger model validation. Unfortunately, if I go this route, I'm going to break clients that are already assuming one of the other formats than the one I pick. Here is an example of how I can enforce a rule stating that each one of the submissions must match the format of @ and then the alias name. I'm using a regular expression here. This would certainly break existing clients that aren't expecting to use the @ prefix or which have been sending URLs. Using a regular expression data annotation also doesn't provide a very user-friendly error message. As the saying goes, when you have a problem and you try to use regular expressions to solve it, now you have two problems. If you do need to validate your model, you'll definitely want to provide better error message to your user than the one shown here. If we want to follow Postel's Law and Hiram's Law as well, then assuming we already shipped a version of the API that allowed for multiple formats of Twitter aliases to be provided, then we should continue accepting all of them so long as we can make sense of them. Then, we can transform the known set of formats into the format we wish to use in our domain or persistence models. Once we have this in place, the API works, as it always has for consumers, and accepts a wider variety of formats without breaking any clients. Essentially, it continues to work the way it always did, but we get the advantage of cleaning up our data and making it so that going forward, we have data consistency. Here is some simple code that could meet the requirements. It's not designed for speed and could certainly be optimized, but it would be clear that there are 3 acceptable formats of Twitter aliases which can be transformed into the canonical @username syntax. Obviously, you would apply this to whatever types your model might use. A common one is physical street addresses, which may be represented earlier on in an API's life as a simple string, and then later on you might add more complex types with separate properties for city, state, etc. Being able to accept types in multiple formats will make your API easier for more clients to use generally, and avoiding breaking those clients that used an earlier format will keep your API working longer.